Have you ever really stopped to think about how when you type a website into your browser, you get exactly where you want to go in like less than a blink of an eye? It's not magic, not at all. It's actually one of the most elegant and honestly essential systems on the entire internet, the domain name system, or DNS. So today, let's pull back the curtain on this incredible digital address book.
I mean, just let that number sink in for a second. Almost 2 billion websites. That's a library with 2 billion books, and you can find any single one you want instantly, without even looking at a catalog. So how on earth is that possible? Well, the answer comes down to two really brilliant ideas: delegation and coordination. You see, the biggest challenge for the DNS is just managing that insane scale. You just can't have one giant single server trying to keep track of every website on the planet. It would just collapse under the pressure, like instantly. So the system needed a way to share the work. It needed to delegate.
So what do we actually mean by delegation? It's a really simple but powerful concept. You just pass the responsibility down the line. A higher level authority basically says, okay, I'm in charge of this huge area, but for that specific neighborhood over there, you're in charge. And that right there is the core principle that makes the whole thing scalable and keeps it from breaking.
This chain of command works exactly like this. Let's take the address a6.es.es as an example. So way up at the top, you've got the .es domain, right? That's managed by a national authority. But that authority doesn't manage every single .es website. Nope, instead, it delegates the es.es domain to another server. And then that server can in turn delegate responsibility for a6.es.es to yet another server. You see, each step just narrows down the search.
But here's the really critical part to understand. Just because you're delegating responsibility, it doesn't mean each level is off doing its own thing, completely independent. It's all about coordination. A server higher up the chain might not know the final answer, but it always knows exactly who to point to next. It knows who's in charge of that little piece it just delegated.
And all of this leads to a pretty simple but really powerful formula for the internet. The more you delegate, the more efficient the system becomes and the faster it goes. By breaking this impossibly huge task into millions of tiny, manageable pieces, the system can operate at that lightning pace we all just take for granted every day.
Okay, so we're delegating tasks. That makes sense. But how do we define the exact territory each server is responsible for? You know, how do we actually draw the map? This is where the idea of a zone comes into play. And this is where we need to get clear on two key terms that sound similar but are different. A domain is the whole branch of the tree. So, for example, isrs.es and absolutely everything under it. But a zone is only the specific part of that tree that one single server is directly in charge of. Think of it this way. A zone is the specific map a server holds in its hands. And the server that holds the master files for that zone, well, it gets a special name. It's called an authoritative server. This means it is the ultimate, final source of truth for that one specific piece of the internet. If you need a definitive answer about a name inside its zone, this is the server that has it, period. All right, so we've got the structure all laid out, this delegated hierarchy of zones, and each one has an authoritative server. But how does your computer actually navigate this whole map? How does it ask for directions? Well, this all happens through a process of asking questions, or queries. And there are basically two fundamental ways a server can handle a request. Think of it like this. An iterative query is like asking a librarian for a book, and they just point you to the right aisle and say, it's over there. But a recursive query? That's like asking that same librarian, and they say, wait here, and then go and get the book for you. One points the way, the other does the whole job. So with an iterative query, the server basically acts like a signpost. It looks at its own local info, and if it doesn't have the answer right there, it just gives the best lead it has, a referral to another server. It's essentially saying, look, I don't know, but you should probably try asking them. It points the way, but it's not going to take the journey for you. A recursive query is the total opposite. It's a full service request. The server promises to find the answer no matter what it takes. If it doesn't know, it takes on the full responsibility of going out and asking other servers itself, following that whole chain of referrals until it gets the final answer to bring back to you. So, which method does the internet actually use? The quick referral or the full service answer? Well, the absolute genius of the DNS is that it doesn't choose just one.
It uses both in this perfectly coordinated dance.
And here it is. This is the secret sauce that makes it all work. When your computer asks its designated DNS server for a website, it makes a recursive request. It says, please go find this for me. But when that server needs to talk to other servers out on the internet to find that answer, it uses iterative queries. It just asks for referrals, moving step by step up the chain.
So why is this combination so smart? Well, first, it's super simple for your computer, which just gets the one final answer it needs. Second, it's really efficient for the whole network, because servers are just providing helpful directions instead of doing all the heavy lifting. And maybe most importantly, this system prevents that small handful of critical root servers at the very, very top of the internet from getting totally overwhelmed. It keeps the whole thing stable and incredibly fast.
So, the next time you browse a website, just take a second to remember this invisible system working like crazy in the background, this incredible dance of delegation and coordinated queries. It's a design that has scaled from just a few thousand computers to billions of them. And the big question now is, how is this elegant system going to manage the trillions of devices that are still to come?